So the title of the talk is OPV for IoT applications, and the specific title is kind of smart power to data. And so what I mean with the smart power to data is with our mission statement, so entering uncharted IoT space. And that means from our perspective, the IoT world is fairly big and will be going bigger and bigger. And the challenge is that when it comes to measuring sensor data, for example, there are only two ways. Currently, primarily, either you use batteries or you manage to tie a cable to the spot where you gather the data. And both these are the main constraints. And there will be a lot more to measure and to detect in areas where there are limits of these two ways. And that's where Enerthing starts. So whenever we develop a new application, we see how strong the constraint by batteries is. And talking about batteries, there's also the other elements. Even if it would run very, very long, there's an environmental issue, no question. So even in Germany, you have nearly 56,000 tons of battery waste every year. It's growing. This was the number from 2019. So it's more than 1.5 billion batteries, kind of different sizes. It would also, if you look at the energy stored in batteries, and if you compare this, then it requires 40 to 500 x of the energy to produce the battery in comparison to the energy that's stored in this specific battery. So it's a very inefficient way to power things. And there will also be a new battery law coming in Germany in the near future in 2023, and that's also coupled to the environmental impact. So this is more, let's say, the environmental view. But then, but we are also specifically interested in the let's say in the limitations and to overcome limitations that batteries present. So, and what you see here on the left-hand side is effectively is the power in average you can draw from a battery over a certain period of time. And I've just given here examples, different types of batteries. So what you find most often is the very small, the coin cell CR2032, and going all the way to AA batteries, AAA batteries, AA batteries, and the very big lithium thionyl batteries. And for different lifetimes, and you see here, so you can draw. And when it becomes painful is if you have to change batteries within, let's say, less than a couple of years, then it becomes painful. And you see here, on the right-hand side, I've plotted the power, the average power you can draw during daytime from a photovoltaic module under indoor conditions. So what we've calculated here is 200 lux illumination or 500 lux illumination for different areas. And what you can see here, that from a certain area at a certain illumination conditions, we exceed the average power from standard batteries. So if you're talking about lifetimes of, let's say, 10 years in the field, because many IoT applications, you would never want to touch the device again, because once you have to touch it once, devices that in fields, then it becomes very expensive. And this is exactly the metrics we always have in mind. Our solutions should last for more than 10 years in the field without touching it, and that makes it then very efficient and also commercially interesting. So talking about our devices, so this is the first image on the left-hand side. You see, for example, our CO2 sensor based on our photovoltaic films. So this is, I will show it here in the camera. So this is roughly what it looks like. And this is the photovoltaic module we've developed and also produced for this. And on the right-hand side, you see performance, so power, for a certain illumination, 200 lux. And this is what we produce on these types of modules from our production line. So these are actual measurements from mass-produced modules. So it's not champion devices, but it's the average. And you can see here we are approaching now 0.5 milliwatt for these devices. So if you look now, we also interested, so this was the focus on indoor OPV, but we also see benefits from outdoor OPV applications. So here, for example, you see there's different metrics. So it's not necessarily the